Hi guys, again we're back to Calculus 2 classes. We'll finish the washer and the disk method. I know the class is a little hard, but if you have any question you can text me to this phone number or just send an email. Also, I need to remind, if you have friends or anyone else and they're looking for SAT classes, we're going to start the SAT soon. The SAT, you know, there's a test coming up in August, and there's too many tests on another date. Okay, now I need my student to come. Can you come here, please? Just, okay, this is, don't forget to like and subscribe. Let us go to our class and solve problem. The best thing to understand any subject is to solve the problem about that subject. Okay. Just quickly, you have to remember that x equal fy. X equal what? Fy, y equal f of x. If you have anything called x equal 3, mean if y equal 3 the same, or y equal 5, mean x equal 5, if x equal 5. Also remember, just let me just take this a little bit down. Okay. Can you zoom to the board, please? And x-axis mean, if you remember, x-axis mean y equals, you remember this? And y-axis mean x equals 0. X equal 0. I need to remember these things. I'm going to leave it for 1 second. When I have x equal 3, that means fy equal 3. Okay. Now, for the disk and the washer method, quickly for the disk and the washer method, what you have to do. Now I'm going to just quickly remind you. If the revolving about x-axis, about what? X-axis, about x-axis, or what x-axis mean, guys? Y equals 0, or y equal any other value, y equal 3, 4, 5, 6, any constant, like C. Then for disk method, 0, a to the b, pi, about x-axis, fy, right, fx square dx. Okay. Now, the revolve about x-axis, y-axis, about y-axis, make everything together about y-axis, about y-axis, or any which is x equal, y-axis mean x equals 0. Right? Y-axis mean, at least you get some point when you set up your integral. About y-axis x equals 0, or x equal 2, you're revolving about what? X-axis. You're revolving, here you're revolving about x-axis. Your disk method is pi integration from a to the b, f, about y-axis, fy dy, fy squared dy. Remember, always there is a radius of revolution, and we call this guy the radius of the revolution. Radius of whatever it is, either x or y, radius of revolution. Okay, the same thing for what? Y, the radius of what? Revolution. Now for the shell method, usually you have what? Two functions. Usually you have what? I'm sorry, not shell, washer. For the washer, or some books they call it what? Some book they call it range. for the washer, for x-axis or y equals 0, you have two functions. You're from A to the B, the big radius minus the small radius. If make believe the big radius is what we talk about x-axis, f of x minus g of x squared. You have to see which one is what bigger, has a bigger radius. For the y-axis, always pi outside, pi is constant. Y-axis, pi integration from A to the B, f of y, right? F of y squared, k, minus, I don't know which function g of y squared has more radius. Then through the problem, we'll see which one has more radius. Some books they call it R, some books they call it R uppercase for the big radius. And they write, some books they write this one as what? R, you see this guy here? They call it Rx squared minus Rx squared. Some books they call it, I'm gonna put it for the Y, some they R out square minus Rn square. Look here, as long as you understand, when you graph, you understand what you need, you're good. Let us start. Let us start with our example to make the concept clear. Example 1. We need to find the volume of revolution when the function y equal 1, we have function y equal 1, another function y equal x cubed. We need the volume of the revolution when we rotate the area between these two functions, rotate the area between these two functions about what? The line y equal -3. Before I start, always I say the hard part in this problem is to set your integral. Then you solve it. Okay, let me just set my integral and show you what I'm gonna do. Okay, let me graph. Okay. You don't have to be accurate in your graph. We need to set to see exactly how the graph x cubed. Everyone knows x cubed is going like this. X cubed. Okay, and y equal 1, let's call it to make it big. Let me just erase and make a line. Okay, make it line. Then I'm gonna, this y equal 1. I'm trying to make it okay, and give it the color red, I mean. Right? Then the area we need to revolve it, this area. Which area, guys? This area, right? The first thing, from 0 to 1, right? Here, this 0, how I get the 1? You're gonna make these two functions equal. X cubed, right? X cubed equal to 1, take the cubic root, x equal 1. Then from, okay, let me just graph the x1, and I'm gonna make it dotted like this. X equal 1, and give it different color, like green. Okay. From here to here, we're gonna revolve this. We're gonna revolve it where? Look guys, we're going to revolve all this area about which line? This line, which is y equal negative 3. Okay. Y equal negative 3, negative 1, negative 2, negative 3. Because I'm counting by 2 for the y-axis. 1, 2. This is my line of revolution. What color you need? Okay. I'll make it more bold to a little bit more. Okay. Just to see it. Okay. This is y equal 1, and this y equal negative 3. Let us see what's going on here. Let me just extend this line, the x equal 1 all the way down. Actually, x equal 1 is here. Okay, I'm going to leave it here. I want to count by 1 for 1, the x-axis by 1. Now, we have, when we revolve this guy here, when we revolve this guy, I'm going to move it here, not that one. When we revolve here, we have two radius, right? We have the first radius, we're going to do, we know our integration from 0, volume, goes from 1, pi, because we're in shell method, from 0 to where? To 1. Which one the big radius? Look here. We need this small area, right? From here to here, right? If you go from here to here, you see that one here to here, we'll see the x cube. We need this one, right? From this to negative 3. To negative 3, this point. So, okay. Any point in this function is x, any point on this function is x and y, right? Any point, and here x and y, as I mentioned before, any point here x and y. Now let us go to this point. What's the distance from here to here? The radius, right? When we revolve it, right? It's going to go to the other side, and the curve will be like this. The same thing, you see that one here is going to revolve, but it's going to be this guy going to be like this, like image, and right, and this guy like this guy here, the revolving. At the end, I'm going to take this up and make this different color, black. You see this guy from here, this line? That give me. Now, what is this guy? This x cube, right? And we have 3 more. And from here to here is, if this x, this y, right? If this x here, where x and where y? Y is going from here to here, and x from here to here for the function, right? Good. Then from here to here is y, but I have also a distance from the y to where? To the line. How much is this distance? 3. Forget the negative 3. But the distance from this point to this point is the value of the function, which is y plus this. Then y plus 3 is my big radius, is r. But I know the big radius. But I know y is what? X cubed. Wow. Okay, good. Then let me explain. For the blue function, right? Which is y equal x cubed. Y equal what? If you focus with me a little bit and spend some time, I need to find the distance between any point on the curve y equal x cubed and y negative 3. I know if I take any point like x and y in this function, this is x and that y. Any point, right? Y means the distance from this point to the x-axis, which is y, because I want to go to revolve it about y equal -3, I need to see what the distance from here to here, right? Then look here, the radius always goes like this, right? This radius from here to here is y plus what? Because it's going to be the other side. I'm going to explain the other side. Then we have y plus 3, x plus 3. And the other one, look here, this one. This is the bigger one. The other one in different color, like this. It's constant all the time. Y, look here, from here to here. How much from here to here? Anyone can tell, because this straight line, constant function, right, guys? Constant function. The distance from here to here is 1, and from here to here 3. Then the small r equal how much? 1 plus what? 3. We disregard the negative because we're looking for the whole distance. The first one, y plus 3, and I know y x cubed. I'm not. Then my small r and then r. Then y plus 3 squared. Y is x cubed. Then x cubed plus 3 and square, apply the formula, minus 4 square and dx. Then you do the integration, and you do your integration and you finish your problem. Again, all what you need, because we have two functions, y equal 1. Y equal mean f of x equal 1, right? I told you this one before. If you go back to that, what I mentioned at the beginning. What I mentioned at the beginning, x equal 3, y equal 5, equal f of x equal 5. Okay. Then all what you have to do, let me move this guy a little bit to finish my integration quickly for you. And sometimes I'm going to leave some integration for you. R equal 3 is either. Let me just put R equal 3 on this side. Now, to finish this integration, first what you have to do, guys, first you leave v equal pi 0 to 1. This becomes x cubed, x to the 6, 6x cubed plus 9 minus 16 dx, and this equal x cubed is 8. Now I'm gonna do it one shot step, okay, if you don't mind, guys. 9 minus 6 is what? Minus 16. We are in calculus. 2 9 minus 16 negative 7. Then my final answer will be pi x to the 7 over 7, 6x to the 4 over 4, and I'm going to give this to this minus 7x. And my limit from 0 to where? To 1. Plug 1 and 0, pi, I'm going to leave it for you like this, 1 7 plus 6 over 4 minus 7 minus 0, which is what we don't need. Minus 0, which is we don't need. Now we're done with the first problem, and you finish. I'm going to leave this for you to give you more example. Okay. To confirm this one, let us go another problem like that. Now we have another example. Y equal square root of x. Y equal -1. Y equal, I'm sorry. Y about -1. Y equal, we need to find the boundary. Y equal square root of x, and another function, y equal x squared, and we need x0 and another function. What I mean by x0, I need to revolve the area between y equals square root of x, y equals x squared, and x equals 0. X equals 0 is y-axis, is what? Y-axis. About what? About y equal -1. About y equal -1. Okay, graph it. Graph this. Quick graph. Okay, I have time, right?
You have like 5 minutes.
Okay. I need more. Let me read this problem. Okay. About y equal. Look here, guys. Y square root of x. When x equals 0, 0. When x equals 1. When x equals 4 is 2. 2 is 0. Okay. Y equal x square. Everyone know what x square. 0, 1. Negative 1 is 1. 2 is 4. And 1. 1. 2 is 4. Okay, you see that. Okay, I need to make it bigger, to enlarge it. Make it count by 2s. I'm going to count by 2s. It's better than every 2 is 1. What I need, I'm going to extend to make it, I'm going to enlarge my graph. Okay. What I mean when here, I mean by this, when x equals 0, this 1 and this 1, this is 2, 3, and this 4 comes to the 2. I'm going to enlarge it. That's better. And when x, this 1, 1 for the y, for the x square, when it's 2, 1, 1, 2, 3, 4, right? When x, I'm gonna end with 1. When 1 and 1. Then y is x squared in red. Okay. X squared and 100. This is x squared and this is square root of x. Now the area I need to revolve is this. And I need to revolve it about the line y equal negative 1. The line equal what? Y equal negative 1. Negative 1. Okay, just as we did before, we're going to make it green and bold it. And big. Okay. And we need to find this point. Again, I'm going to go to this line, which is this point. Because of my integration will go from 0 to this point. And this point is, I'm going to make it a little more here. Okay. How we find this point? By make these two functions equal. X squared equal square root of x. Square both sides. X to the 4 equal x. X to the 4 minus x. U minus x equal 0. X cubed minus 1 equals 0. Then x equals 0 from this, or x cubed equal 1, or x cubed equal 1, or x cubed minus 1 equals 0, x cubed equal 1, which is x equal 1. Then I know from 0 to 1, then x equal 1. This is my A. Now I need to find my two R's, the out, the big and the small. The big, right, and as I said before, the big and what? The small. Let us go to the square root of x, which is, as I said, if you take any point in the square root of x, I'm going to take it in this color here. From here to here is what? Square root of x. And how much we have here? Extra. We have 1, right? Then the big radius, Rx is square root of x plus 1, right? Which is the bigger one. For the other one, the red one, let me take it in green. From here to here, if you have any point x and y here, From here we have the y, which is the same function, right? Y for the x squared plus what? Plus, then the small one comes from this, the x squared, right? Which is x squared plus what? 1. Good. Now, my volume, I have the big and the small. My volume, pi, from 0 to the 1, the big minus the small, square root of x plus 1 square minus x squared plus 1 square dx. Now it's integration. After I said my integration is going to be very simple to finish. Pi, I'm going to do it 0 to the 1, x, let's see, do this one, plus 2 square root of x plus 1 minus, remember we have minus, I'm going to apply the minus into the, my x to the 4. X to the 4, everything will be minus 2x squared minus 1. This cancels with this, right? And everything dx. Remember square root of x, remember in the side, square root of x equal x to the half. When I integrate it, I'm going to apply x to the half. Then pi x squared plus 2 x and a half. If you integrate it, you're going to add 1 here. It's going to be 3 over 2. When you put it here, 2 over 3, right? 3 over 2, it's going to be 2 over 3, x 3 over 2. You see what I did here? And for when you integrate that, this guy, 1 half plus 1, 3 half. If you divide it, it's going to be 3 half in the bottom, but you're going to take it out, become 2 over 3. 2 over 3. Okay, and minus x5 over 5 minus 2x cubed over 3 from 0 to the 1. 0 will not affect me. I'm going to just apply the number and leave the rest for you. Pi 1, look, everything is 1, plus 2 times 2, 4 over 3. 1 to any power is 1, minus 1, 5, minus 2 over 3, and everything minus 0. Guy, I wish you understand this, and next time I will finish my problem or practice about the last class next time. Then after this class, after I finish this, I'm going to go to the shell method of integration. Thank you guys, and have a nice day. Don't forget to subscribe and like, please. Thank you guys.